Okay, so grade 7 girls, yesterday you have watched a video of ocean waves where we studied how's the wave. What is an ocean wave? It is a disturbance that transfers energy. Then I have shown you this picture clear where it shows you the crest, the trough, mainly the difference between the two crests, which is called as wavelength, and half the way this is called as amplitude. So this is all what we have learned in your yesterday's class. And then I told you about earthquakes, how the waves are formed in earthquakes, how it affects volcanoes, underwater volcanoes, and even that has so much of energy that causes large waves or big waves. Underwater volcanoes cause waves in a very similar way to how underwater earthquakes. When you see them, they're almost very similar. The surrounding water is displaced, sending out wave in all directions. And here, pushing up the bottom. You know, this bottom, it pushes up more high, and the water, it moves. Landslides, underwater landslides also displace water and cause waves. Meteorites, these are very rare, girls. Maybe this happened long ago. Meteorites and asteroids are rocky bodies from space that collide with Earth. If a meteorite or asteroid lands in the ocean, it comes and it hits the ocean. It can displace enough water to cause large waves. If a large asteroid landed in Atlantic Ocean, for example, the resulting wave would flood much of the east coast of United States. They said almost the East America, East US will be flooded if in case an asteroid, a larger asteroid come and bangs. And then we even studied how the waves and what is the, draw an arrow to show the direction of the movement of energy. They have shown us the movement of energy. Now, girls, yesterday when you were seeing, there was a device called as Buoy, B-U-O-Y, which gives you exactly how fast is the wave. How fast is the wave? And then we studied about the wavelengths are shortened, the wavelengths are constants, and finally the breakers form. How what happened when a wave reaches the shore? By the time it reaches the foam and how reaches the shore, how the breakers form, why the waves stop, who stops the wave? Energy decreases with depth. As you know, as it is flowing wave by wave, finally the energy decreases and it breaks in the shallow water. Strong waves, girls, strong waves can even throw boulders and other debris up on the beach, particularly during storms. You know, you could see those sand particles, those sand debris, you can see the rocks. Now, the energy of the wave and the angle at which the wave hits the shore, it determines how much the energy is transferred. What is a tsunami? Even that day I was trying to show you a video. But even the best surfers would not be able to handle a tsunami. Even one person is a best, what do you call as, what do we say? He or she's best swimmer, or he's or she's aware of tsunami, that tsunami is gonna come, but nobody can control this. It is a series of waves that forms a very large volume of ocean water that is suddenly moved up or down. The movement can be caused by earthquakes. It could not only earthquakes, it could be because of volcano eruptions, landslides, or because of meteorite and asteroids. Most tsunamis occur in the Pacific Ocean because many earthquakes occur in that region. Pacific Ocean because many earthquakes. Tsunamis can reach more than 30 meters in height as they slam to the coast. They destroy everything in the path. The huge volume of water it crashes ashore, then rushes back into the ocean. This powerful flow of water is called undertow and destruction as the tsunami itself. Let me show you this Hawaii. Hawaii and tsunami. Wait a minute.
Of any potential for tsunami waves.
So guys, this is the latest news that was of last month. They said, and the magnitude is like how strong is the earthquake? That's what's written, seismic activity. The magnitude is 8.0. When I was explaining you the lesson earthquake, that time I told you 8.0 is like, it caused lots and lots of destructions to buildings, it can damage the whole city in 8.0 magnitude.
Would be 4:35 this afternoon. So we'll continue to track the situation. But again, the National Weather Service has now issued a tsunami message with that tsunami watch posted. It's effective as of just less than about 20 minutes ago. This happened at 9:28 our time, that big earthquake that was about an 8.0 magnitude. Now, based on all available data, it does look like a tsunami may have been generated by this earthquake that could potentially be destructive on coastal areas, even far from the epicenter. So an investigation is currently underway to determine if there is a tsunami threat to Hawaii. Now, again, if the tsunami waves do impact the islands, the estimated earliest arrival of the first tsunami would be 4:35 this afternoon.
See, this is just what they have suspected. They suspected, and they made an alarm for the whole city that it might spread, because it is not in the city. That epicenter, that focus epicenter is very, very far away from New Zealand, or very far from Hawaii. But still they plan everything, and they said that it is expected that the waves may roll out till 4:35 p.m. Imagine 9 o'clock in the morning, the earthquake, maybe that's only for a few seconds, but later at 4:30 it is being expected. So these kind of news, they come before the recording the seismic activity. Now shooting footage of 2011 tsunami hitting Hawaii. But again, that what you call as, it won't be clear, but let us see.
Let's bring a smile to their faces.
That is big. That is absolutely massive. Just lost my shoes. This is coming straight over the wall onto the main road. That is absolutely unbelievable. Here it comes again. Pouring over the wall. You can see a car making a run for it out there. I am completely stranded.
One splash can, ruin all of those shops and everything. New Zealand. Anyways, that's it. So let us go for page number 76. A wave speed is equal to dash multiply by its. You have to multiply the wavelength. You remember I told you what is a wavelength? I have said you before that if this is the difference between from here to here, this is called the wavelength. So how do you calculate the wave speed? By multiplying this with the frequency. If I multiply the frequency with the wavelength, I get the wave speed. Now, wave forms when energy is transferred to ocean water by wind, landslides, wind, ocean by water, wind, earthquakes and volcano, landslide, meteorites and asteroids. And finally, waves transfer energy, not matter. When a wave approaches the shoreline, it slows down. Again, this is important, girls. Waves form when energy is transferred to ocean by, how is it transferred? Either by earthquake and volcanoes, meteorite or asteroids, landslides, wind, by wind. That's it. Now here, I want you all to do this. Julie, what is the top most it is called as? What is this called as? Number one. Noor, number one. Zishan, anyone please tell me what is number one as?
It's
Okay, I will give you options here. You choose and tell me.
okay.
I will write down here. Come on.
Crest.
It is a crest. Excellent. Number one is crest. What is number three, Noor? Number three.
Wavelengths.
Yes. And number two is trough. Okay. So this is the most important thing what you have to learn in this lesson is about these three things. You must know what is a wave and what is a tsunami. What is a wave period? Again, wave period, when you multiply this wavelength to frequency, you get a wave period. That is a wave speed. I think wave speed. Yes, that is a wave speed. Wave period is in contrast measurement of how much time it takes for a wave to pass the fixed point. How much time it takes for a wave to pass a fixed point.